What's up everybody? I'm Paul, you're watching 3D World, and today we're going to go over how to avoid failed 3D prints. These are just a few tips that I wish I was aware of when I was getting started, and I wanted to share them with you and hopefully make your lives just a little bit easier. Let's take a quick look at the hardware side of things, and then we'll jump on Cura and go over some software settings that you can implement that'll increase your chances of success. Now, let's start from the ground up. The bed needs to be clean. I've had failed 3D prints just because my bed wasn't clean. If it's covered in dust, residue from old prints, or some sludge from adhesive that you used previously, grab yourself some dish soap or some isopropyl alcohol and wipe it down real good. Make sure it's clean and dry. From there, bed leveling. I'm going to do a detailed bed leveling video in the near future. But for now, a quick tip is make sure you're doing your bed leveling procedure at the same temperature you're going to be printing at. If you did your bed leveling at room temp and you're printing at 60 degrees Celsius, you're not going to have a good first layer. And the first layer is the foundation and the building blocks for the rest of your print. It needs to be perfect. It needs to be adhered well to the build plate, and if it's not, the rest of the print is going to be inaccurate. It could shift and you can have all kinds of problems. Here's an example of a failed first layer. It started curling or warping, and I went with a brim for my adhesion type, and it didn't get the job done. So I sprayed down a little bit of hairspray, and I changed it to a raft for my adhesion type, and I'll go over those terms a little bit more when we get on the Cura side of things. And now the print seems to be working out very well. This is a 3D model of a house that I put together on SolidWorks, and yeah, so make sure that your first layer comes out good, or you might as well start over. From there, let's stay on the subject of temperature. Each kind of filament that you're using has a suggested temperature range. I got some cheap PLA filament on Amazon. This is Overture PLA, and the nozzle temp suggested temperature is 190 to 220. And the bed temp is 25 to 60 degrees Celsius. I'll tell you right now, the 220 degrees on the nozzle temp is way too high, and 190 is too low. I like to print PLA at 200 degrees Celsius, and that's probably a good starting point for whatever machine you're working on. And if you increase or decrease it and notice that it helps or hurt your problem, then you can make adjustments from there. And you can do the same thing on your bed temp. I like a higher bed temperature because I feel like I've had more success with adhesion that way. So staying on the subject of temperature, if your first layer is good but you notice some cracking or warping further into your print, it may be because of your environment temperature. So ABS, for example, is much more difficult to work with than PLA, and you're almost always going to need some kind of enclosure to keep that climate at the right temperature so that your print doesn't warp or crack with that extreme temperature change from coming out of the nozzle to just being in the open air. So that's something to keep in mind. Lastly, I'll quickly touch on mechanicals. I've had a few failed 3D prints just because my spool got tangled or the carriage bumped into it, so I had to move my filament roll around a few times where it was mounted, and you want to make sure that it can rotate freely, and you want to make sure that it doesn't get tangled and tug on the carriage, because if it does, your print's going to start in a whole new location in the bed, and that's obviously no good. Other than that, make sure that your belts are tight and you'll be alright. Anyway, from there, let's take a look at Cura. First thing we'll do is add the printer we're working with. If you got a name brand printer, it's probably already in their library. It's fairly extensive. Add it, and your bed size and your print area and all the other settings will be taken care of for you. You can move on, click this file icon, and import the Stl file that you're working with. I like to think about what portion of the print are people going to see the most, and I want to avoid having any support structure on that portion of the print. So I just rotated it, and snap rotations enabled, so it went down on the bed real nicely, and all my support is going to be underneath and won't affect the area that people are going to interact with. So the reason for that is if you have to scrape off support or whatever the case, it's not going to mark up the area that you want to look the nicest on your print. From there, you can scale it if you want to increase or decrease the percentage. You can move it on a different area of the print bed if you'd like. But let's take a look at our basic settings. So layer height is what we have up top here. Layer height is literally the size of the layers that you're going to see on the print. So the lines on the print, if you want them to be smaller and you want to have a higher resolution, you can decrease this and it will increase the amount of time that your prints take. If you're printing something large or you're doing some finishing work to it anyways, you may want to increase your layer height, and that will help your print get done faster, but it will have larger lines. Moving on, infill percentage. I associate this with strength. The default percentage is 20%, and I like to go with 40. I need some dexterity and strength to my parts. Give you something to think about as far as infill percentage. If you're printing something that is hollow, so the shell is the only spot that's going to be affected by infill percentage, so the outer layer of whatever this hollow object is, it's not going to take the print that much longer to increase the infill percentage on just that outer layer, that shell. If what you're printing is a completely solid object and is not hollow, then it will tremendously increase the time that your print will take to increase your infill percentage. Hope you're following me there. So something to think about also, if you have a really skinny portion of something that you're printing, it's going to need to have a higher infill percentage if it's going to hold up through the printing process, let alone being handled afterward. So you don't want to have flimsy parts come out, then you might want to increase your infill percentage, even though it'll take a little longer to do to get through your print. Let's take a look at support. We're definitely going to want to generate support because all the parts of the print that are not touching the bed need to print on top of something. And support placement, we're going to go ahead and leave that everywhere. You know, if it was only the spots touching the build plate, we may have some areas that don't get supported properly. Now, support overhang angle. We're going to leave that at 30. 90 degrees would be literally none, whereas 0 degrees would be absolutely everywhere. 30 degrees seems to be working fine for me. Build plate adhesion type. We were talking about this earlier. A skirt isn't really going to give you any support at all. All it's going to do is prime the nozzle so that when you do get to your print, the nozzle is extruding. A brim is going to give you a limited amount of support, and it's going to give you several layers around your print that are contacting the bed, but your print is still going to have contact with the bed, which could lead to not enough adhesion. Now, a raft is kind of like the boss of adhesion types, so it's literally going to give you 100% surface area contact with your bed, and then your print is going to be on top of that layer. So it'll take longer. It might take you a while just to print the raft, and then your object's going to get printed on top of that. But if you are struggling with adhesion, this is one of the first things that I would try doing, is changing to a raft as far as your adhesion type. Temperature, again, make sure you're following what your filament rule says. PLA, I've had success with 200 degrees Celsius and 60 degrees for my build plate temperature. Speed, if you've gone through a print a number of times and it seems to be working out fine and you're churning out a bunch of them, you might want to try to increase your speed and make you a little bit more efficient. Or if your prints are failing and their quality isn't as high as you'd like and your machine is shaking around like crazy, that's a good sign that you need to decrease your print speed. So that's all I wanted to go over for today. These are a few little things that hopefully will turn into common sense for you, but this is the settings that I like to go with before I slice my STL files and turn them into G codes that the printer can then go ahead and output. Hopefully this was helpful for you, and thanks for watching.